Um, First part we're going to do is we're actually doing distributing, and you've done distributing before. Okay, you've done distributing before. Bless you. So it's not anything new. The main difference with the distributing you're going to be doing today, or starting today, is that you're going to have more variables involved. Okay, you haven't had a lot of variables involved in the past with the distributing you've done. Usually there's one that's been there and hasn't made any changes. Starting today, you're going to have other variables involved, and you're going to have changes to exponents made. Because remember, when you multiply, you add the exponents. Yesterday we talked about this with adding and subtracting. Exponents do not change. When you add and subtract, your exponents do not change. Nothing about the variable changes when you add or subtract. However, today we're going to be doing multiplying and factoring, which is essentially dividing, but it's a little bit different. You're going to have to, your exponents are going to change when you multiply and you factor. Your exponents do change. So you have to be careful of that. So we're going back to the rules, but it's a simple one. You're adding exponents for multiplying, and when you're factoring, you'll be doing subtracting of exponents. So it's not that bad. So let's take a look at this first example here. I have negative 5x times 2x squared plus 3x minus 8. Remember, on the x, what do I have? I have an unwritten 1, and I have an unwritten 1 on the exponent there. Okay. And like I said, we've done distributing before. When I distribute, I take the negative 5x times everything that's inside, and I do it one at a time. I multiply the numbers first. Negative 5 times 2 gives me negative 10. And then I have x to the first times x squared. What do I have for my x's? X to the third power, because what do? You add the exponents and you multiply. I got a 1 and I got a 2 of x to the third. Okay. So there's my first term, and then I do it again. Negative 5x times 3x. Negative 5 times 3 gives me negative 15. And then x to the first times x to the first gives me x to what power? X to the second power. 1 plus 1 is 2. Okay. And then I do it again one more time. Negative 5 times negative 8. Watch your negatives when you're multiplying. Negative times a negative, that'll give me a positive. 5 times 8 is 40. And then what about x's? I combine them. Do I have an x on the 8? No, so I just take the x that I had with the 5 and I just stick it on there. And that's your answer. Easy peasy, right? Careful with your exponents, careful with your negatives and positives. You've done distributing before. I'm not really all that worried, but do watch your exponents. They will change from multiplying. They didn't change yesterday, they will change today. Okay. Now this one's a little different. You haven't seen this very often. I have 9 minus 2b times 5. Well, that's the exact same thing as if I take this and move it to the front. It doesn't matter whether it's on the front or the back. I'm still multiplying everything inside times that 5. Doesn't matter whether it's front or back. Okay. So if I move it to the front, same thing. 5 times 9, I just do 5 times 9. 45. And then I do 5 times 9b, which gives me negative 10b. Okay, piece of cake. Question. What's it? We've done this before. This is not anything new. Okay. However, this is new. And this is where the difficult things really start to happen with what we're doing in here. Factoring. Okay. Factoring, the opposite of distribute. You pull out the greatest common factor and out of all of the terms. So what we're doing is we're basically, with this one, we are undistributing. The answer to to factoring looks like the problem for distributing, and vice versa. So we start with things that are distributed. Our answer is going to look like the problems we did with distributing. We're going to have something out in front and stuff left in parentheses. We're undistributing. Gavin, that's not for you. Your hands work. No, that's not for you. Your hands work. Thank you. So, pay attention. This is where it gets difficult. We have two things we need to worry about. We need to worry about numeric factoring, and we need to worry about variable factoring. Okay? So when I look at 2y minus 2y plus 12, I need to pull out the greatest common factor. So what I look at is, what's the largest, ignoring the y? I have 2 and 12. What's the largest number that divides into 2 and 12? What's my factor I can pull out? What divides into 2 and divides into 12? 2. Is there anything bigger that goes into either one of those? No. It has to go into both of them. So 2 is my common factor. I can pull a 2 out. Now the next question I have is, do I have a variable in both terms? No, I don't have a variable in any more than the first term, so I'm done with that one. Okay, gentlemen.
Should I take their phones?
Put them away. Last chance. You guys know you're not supposed to have them out, right? Guys. So I pull out a 2. Okay. What's left behind? What I'm doing essentially is I'm dividing both of those terms by 2. Yeah. So when here, this one here, the 2's canceled. The 2's are gone. I had a 2. I took the 2. What's left behind? I have a y that's left behind. I have to have that y that's left behind. Okay. This one, I had a 12, and I have a plus in front, so I still have a plus here. I had 12. I took out 2. What's left behind? 6. I undistributed. That's what factoring at this time is about. It's about undistributing. Okay? I look for something that's in every single term that I can pull out. My answer to this problem should look like the problem I had for distributing. But basically, the things we're doing today are undoing each other. Okay? Let's take a look at this one here. 3 and 18. What am I going to pull out? What goes into 3 and into 18? 3. 3 divides into both of those. And sometimes it's the number in front, sometimes it's not. It may get a little more difficult, but right now on this one, hey, I've got a 3 goes into 3 and 3 goes into 18. So I can pull out a 3. Now the variables is where it gets a little tricky. I do have a variable in every term. So I'm going to pull out an x. How many x's do I pull out? What's my smallest exponent? I have x squared here. I have an x to the first there. What's my smallest exponent? X to the first, right? So that means I'm going to pull out the smallest exponent is what gets pulled out. I pull out an x to the first. So I pull out 1x. Okay. So I always look at it 2 things. What's the number I'm going to pull out? What's the variable I'm going to pull out? Sometimes I can't pull out one or the other. On the first one, I didn't have a variable I could pull out because I didn't have a variable in every term. It has to be in every term. Okay. This is not my answer. That's just what I'm pulling out. I also have to have what's left behind. Now, when I pulled the 3 out of here, what was left behind on that? X over 2, right? Or sorry, the x's are gone. So the 3's cancel, and what did I do? So I don't have any numbers left with that one. But I did have x squared. How many x's did I take out? 1. Took out 1. I had 2 and I took out 1. So what do I have left? I have 1. I have x to the first power. I had 2. I took out 1. That means I have 1 left behind. Okay. And then I had a minus here. I have a minus here. I had 18. I pulled out the 3 out of the 18. What's left behind from that one? 6. 18 divided by 3 is 6. What about my x's? How many x's did I have? I had 1. How many did I take out? So if I had 1 and I took out 1, how many are left? None. That's my answer. Yeah.
So for the x over 2,
Mm-hmm.
how'd you get x over 1 when you brought it down? If you shouldn't have,
Oh, this isn't a 2. This is a 3. Is that what you mean?
no, like the power.
Oh, the powers.
Yeah.
Okay. I'm going to tell you this, and please understand, it's sometimes a difficult thing to wrap your head around. It's a good question, though. What I'm doing is I'm actually dividing. So I'm actually dividing this by x to the first. But sometimes it's hard to think about it as, oh, I'm dividing by x to the first. So I had 2, I took out 1, what's left behind? I often like to think about it as being exponents. I had 2 x's in my exponents. I had 1, I took out. So I had 2, I took out 1, what's left behind? If I have 3 and I take out 2, what's left behind? It'll be 1, because sometimes we'll take out more than one of them. Okay? Any other questions? Okay. So, first problem, distributing. It's not that bad. We've done this before.
Totally.
Difference with this one. Okay. Drake.
Okay.
Drake. Or go.
Can I give it to you? Or can I put it in the
Put it in the pouch for now.
Well, there you go.
Drake.
Literally just when you saying that doing absolutely nothing. I was checking something.
I know.
Dude, the only time I ever got Tyler.
Drake.
What?
That's enough. Buddy, go. Okay. So distributing. Okay, you've done this before. Big difference is now you've got variables involved, or I should say exponents involved, where you didn't have a lot of exponents involved before. So this is kind of going back to what we just got done. It's really not difficult. I take negative x cubed times negative 9x to the 4th. The negative in front and the 9 just give me a negative 9, not a big deal. When I'm multiplying, what do I do to my exponents? I add them. So I have 3 plus 4, that gives me x to the 7th power. And then I do it again. Negative x times negative 2 gives me what? Plus 2. And then my exponents. Yeah, I have 3 plus 3 gives me 6. And I do the last one, and then, yeah, the negative and the 7 give me a minus 7. What about my x's? It'll be x to the 3rd, because I don't have any x's here, so I just have this one there. Okay. Question. Okay. Now is where the fun really starts. 5x cubed, 25x squared, 45x. We're factoring out. We're doing the same thing we did at the end. I need to pull out my common factor, and then I need to figure out what's left behind. So I always look at 2 things. First thing I look at is my numbers. I've got 5 and 25 and 45. What number divides into 5 and 25 and 45? 5. So 5 is what I'm going to pull out. So I have a 5 that I pull out. Now do I have a variable in every term? Yeah. What's my smallest exponent? 1. So my smallest exponent is 1. That's the one I pull out as the smallest exponent. In this case, it's a 1. That's my common factor. Do not get confused. I have several students that will take the test, and they'll tell me this is the answer. This is half the answer. I still have to have what's left behind, not just what's pulled out. Okay? So now I go through, and I take this out of every one of the problems. Now, with the 5x cubed, I pull out the 5. So numerically, what do I have left? I just have a 1 here, right? And normally I don't write the 1s, but to make sure it's there. What about the x's? I had 3. How many did I take out? 1. So I'm left with 2x squared. Okay. And then I go to the next one. I do the same thing. I have plus because I had plus there. I took out the 5. So I had 25, pulled out 5. What's left behind? What's 25 divided by 5? 5. Remember, you can use your calculators if you need to. And how many x's did I have? I had 2. How many did I take away? 1. So I got 1 left. And then plus. Okay. I had 45. Remember, I took 5 out of there. So what's 45 divided by 5? 9. So I have a 9 plus 9. How about the x's? Yeah, I had 1x. I pulled it out. I don't have any x's left. Boom. Okay. The next one's a little bit more difficult. Not bad. Once again, I got to figure out what I'm pulling out. I got to figure out what's left. Numerically, 13 and 26. What do you think I'm going to be able to pull out? It's either nothing or it's 13. If you're not sure, here's what you do. Take 26 divided by 13. If 13 goes in there evenly, then 13 is a factor. If 13 does not go into 26, then it's not a factor and you don't pull any numbers out. That can happen. It could be that nothing divides into any of the numbers. Then you have a 1 and you just worry about pulling out variables. Okay? 13 does go into 26, so 13 is what I pull out. Do I have variables in both terms? What's my smallest exponent? 3. So what am I going to pull out? I'm going to pull out an x cubed. This is where things start to change on this one. Okay. So I had 13, and I pulled 13 out. What do I have left here? I have a 1, right? Okay. What about my x's? How many did I have to start with? I had 5. How many did I take out? 3. So I'm left with 2. So I have x squared. I had 5. I took out 3, so I'm left with x squared. Okay. And then I have plus.
13.
I had 26. I pulled out 13. What's left behind? 2. 2 times 13 gives me 26, or 26. Divide that by 13, you get 2. How about my x's? I don't have any more x's because I pulled all 3 of them out. You will have one term, if you pull out variables, you will have one term that has no variables in it. It'll just be a numeric value. Okay? You will have something left behind for sure. Okay? But it isn't always one that we pull out. It's always whatever the smallest variable is, that's what you pull out on that one. Okay? Questions? This is tricky stuff sometimes, so you've got to be careful while we're working with it.